Here's how to add logarithms, subtract logarithms, and what to do if you have an exponent inside of a logarithm. So let's go over the first property of logarithms, which is what you do when you're adding logarithms together. So for these first two properties, it's really important to know that these bases need to be the same for this to work. So if you're adding a log base 5 of something with a log base 7 of something, then you can't do this. Now, the rule is that when you're adding two logarithms with the same base, the same small number, then what you can do is you can combine them into one log with the same small number, and you multiply the big numbers together. So in this case, 4 times 9 is 36. So just remember that when you're adding logs, you multiply the insides. Now this was kind of hard to solve before because log base 6 of 4 and 6 of 9, those are going to give you completely random numbers if you put them in a calculator. But now that we've combined them, we see we have log base 6 of 36. Now if you don't exactly remember what a logarithm is, I do have a video on that you can watch on the card on the screen right now. But just remember that a log is the opposite of an exponent. It's what exponent do you need to put on the small number to get the big number. So in this case, we would need to put an exponent of 2 on a 6 because 6 squared makes 36. So that means that our logarithm is equal to 2. And 2 is our final answer. So all of these properties that I'm going to show you also work the other way around. So we can combine two logs into one log by using that property. But we can also split up one log into two different ones. So we could solve this by multiplying 16 times 8 and then finding log base 2 of whatever big number we get. But that might be kind of hard. So instead, we can see that because these are being multiplied together, we can just do the opposite of the rule we just did. Remember that you multiply the insides when you add two logs. So we can split this up into log base 2 of 16 plus the log base 2 of 8. And remember that these logs are not being multiplied with each other, they're being added, because when you add two logs, you multiply what's inside. And now these are simpler logs that we can solve on our own. So what exponent do you need to put on 2 to get 16? Well, you need to put an exponent of 4, because 2 to the power of 4 is 16. So this log right here is equal to 4. And now this log over here, log base 2 of 8, well, you have to put an exponent of 3 on 2 to get 8, because 2 times 2 times 2 is 8. So this log is equal to 3. And if we just add these together, we get 4 plus 3, which is equal to 7. So this log right here is equal to 7. So that's what you do when you need to add logs together. When you add logs, you multiply the insides. But what do we do when we're subtracting logs? Well, as long as both bases are the same, just like before, we can do a different special rule. When we're subtracting logs, we can divide what's inside. So when you add, you multiply the insides, and when you subtract, you divide the insides. So we can combine this into one log with the same small number, which is 3. And on the inside, we're going to divide 243 divided by 81. And if you put this in your calculator, you'll get 3. So we've combined these two logs into one log, which is log base 3 of 3. So now to solve this, we just need to ask ourselves the question. What number or what exponent do we need to put on the small number to get the big number? Well, if we have 3 and we want to turn it into 3, well, we just need to put an exponent of 1, because anything to the power of 1 is itself. So that means that our log here is equal to 1, because that's the exponent that you have to put on it. So the answer to this problem is 1. And just like before, you can do this the other way, where if you have one log, you can split it up into two different logs. So you could turn log base 3 of 3 into this if you wanted to. All right, our final log property has to do with this exponent here. So if you wanted to solve this log normally, you could put in your calculator 16 to the power of 5. That's going to give you some huge number. And then you have to figure out what exponent needs to go on 4 to get the huge number. And that would be kind of hard. But we have one more power rule that we can use for logs. So this power rule says that if you have an exponent on the inside of your log, then you can take it out and move it to the front. So we can take out this 5 and move it right here in front. And remember that when you have a number and some letters next to each other, that means they're being multiplied. So this log used to be log base 4 of 16 to the 5th. But now that we move the number out to the front, it is now 5 times log base 4 of 16. And log base 4 of 16 is a much simpler log that we can solve on our own. So what is the answer to this log here? Well, it's what exponent you have to put on the small number to get the big number. Well, to turn 4 into 16, you have to put an exponent of 2, because 4 times 4 is 16. So that means that this log is equal to 2. But remember that we're also multiplying it by 5, and 5 times 2 is 10. Which means that this complicated log up here is equal to 10. And as always, you can do this the opposite way as well. So if you had a number in front of a log, you could move it back up as an exponent if you wanted to. So those were the 3 properties of logs: adding them, subtracting them, and then moving an exponent. But what I haven't shown you yet is probably the most important reason why we need to know properties of logarithms, and that is to solve logarithmic equations where you have like letters inside of your logs. So if you want to learn how to solve those, you can watch this video right here. And as always, if you have any questions about this video, go ahead and leave it in the comments and I'll be sure to answer your question. Thanks for watching.